I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. So in this session, we will learn about 8255 IC. So here 8255 means it is Programmable Peripheral Interface, which we can also call as PPI, Programmable Peripheral Interface. Now, so here we will cover the topics like what is the need of that IC 8255, which is called PPI, and we will learn what are different features of that 8255 IC, and we will see the pin configuration of 8255, architecture of 8255, and then we will see what are different operating modes of 8255 PPI. Now, so coming to the introduction of 8255 IC. So here PPI is a general purpose programmable I/O device. This 8255 IC is mainly designed to interface the I/O devices like ADC, analog to digital converter, that is DAC, digital to analog converter, ADC, analog to digital converter, and keyboard. So all these are different I/O devices. So all these I/O devices will be connected to 8086 microprocessor by using this 8255 PPI. And so here we can program it according to the given condition. Why? Because in this 8255 IC, we will have one important register which is called CWR, Control Word Register. So using that control word register, we can program that IC at any condition. And so it can be used with almost any microprocessor. So it is a compatible IC. We can use this 8255 IC to connect different I/O devices. Not only for 8086, we can also use that for 8085 microprocessor also. And so this 8255 PPI, Programmable Peripheral Interface, that IC consists of I/O ports. Okay, so totally here it consists of 3 ports. They are port A, port B, and port C. So all the 3 ports are I/O ports. That means port can be used as input port or output port. Okay, so each port size is of 8 bit. That means in port A we can see 8 bits, in port B we can see 8 bits, and in port C also it consists of 8 bits. Now, so we can assign different ports as input ports or output function. Now, so here, what is the main purpose of using this PPI? So, Programmable Peripheral Interface. So, its IC number is 8255. So, here the main question is, can we connect the input or output devices to 8086 microprocessor directly? Okay, so that means here, if we consider any input or output device, can we connect that input or output device to 8086 microprocessor directly? So here, the question is no. Okay, so the input or output device cannot be connected directly to 8086 microprocessor because this 8086 microprocessor is not having ports. So that is why we are going to use a mediator IC that is called 8255, which is called PPI. So these I/O devices should be first connected to this 8255. Then that 8255 will be connected to this 8086 microprocessor. So this is the basic concept that is behind this 8255 PPI. So if we consider here, this is a microprocessor. So let us consider here, this is 8086 microprocessor. And we need to connect this input or output devices to this 8086 microprocessor. So since 8086 is not having I/O ports, this input or output devices should be connected to 8086 by using this 8255 PPI IC, because this 8255 PPI is having IO ports. Okay. So as we know, the IO ports are here, port A, port B and port C. By using any of that particular ports, IO device can be interfaced to 8086 microprocessor. Okay. So here totally in order to make the data transfer between this 8255 and microprocessor, it is going to use the system bus, which consists of address bus, data bus and control bus. Now, so we cannot connect input or output devices directly to 8086 microprocessor, okay, because it is not having input and output ports. So because of this reason, you have to connect that input or output devices to 8086 microprocessor by using the IC 8255, which is called PPI, Programmable Peripheral Interface. Now, so this 8255 IC is a general purpose programmable IO device. It is used for data transfer between IO devices and processor. So that is the main concept that is behind using 8255 IC. So to connect IO devices to 8086 microprocessor, it is possible only by using 8255 PPI IC as a mediator IC. Now, so that is what the main need of using 8255 IC. Now, we will see what are the features of this 8255 IC. Okay, PPI, Programmable Peripheral Interface. So, here are the main features. So, it is most widely used programmable peripheral IC, and it is compatible with different microprocessors. So, you can use this 8255 with 8086. We can use 8255 to interface with 8085. So, to different microprocessors, this 8255 IC is compatible. And another one is, it is a 40 pin IC. So, all these 40 pins will be arranged in the dual inline package. And it requires plus 5 volts DC supply. So, that is the operating voltage. So, another feature is here, it requires plus 5 volts DC supply. So, it will be operating at 5 volts DC supply, and it is used for parallel data transfer. And another feature is, it is having 3 ports. So, here the 3 ports are port A, port B and port C. So, each port is of 8 bit in size. So, by using these ports only, we can connect the IO devices. Each port is IO port. That means same port, that pin can be used as input pin or also output pin. And so, here if you see, these 3 ports, each is of 8 size. And here, these 3 ports will be divided into 2 groups. So, here the 2 groups are, that is 24 bits totally. So, each port is of 8 bit. So, totally 3 ports are there. So, 24 IO lines are available. So, these 24 IO lines will be divided into 12 and 12. So, these 12 bits will be handling, controlling under group A, and another 12 bits will be under the control of group B. And so, here group A means 12 bits. And these 12 bits are the combination of port A, it is 8 bits, and along with that we also have port C upper bits. Okay, so port C is also of 8 bit, but only it consists of upper bits. So 8 plus 4, this is group A consisting of 12 bits, and another one is here group B, and group B also consists of 12 signals. It consists of port B 8 bits or 8 lines and port C lower lines, that is 4. Okay, so totally 12 IO lines will be under the control of group A and another 12 lines will be under the control of group B. And so another features are this 8255 IC can be operated in two modes. So here the two modes are, one is basic IO mode, so which is called basic input output mode. Another mode of operation is BSR mode. So here BSR stands for bit set reset. Okay. So these are the two modes of operation or operating modes of this 8255 PPI. And so out of these two modes, here we can see BSR mode. So BSR mode can be operated only for port C 8 bits, whereas another mode is here basic input output mode. So basic input output mode can be supported for all the three ports, port A, port B and port C, and it can be operating in three modes, mode 0, mode 1 and mode 2. Now, so out of these three modes, M0 and M1, that is mode 0 and mode 1, can be operated under group A and group B, whereas mode 2 can be operated only under group A. So these are the two operating modes of 8255 PPI. And so this is the schematic diagram of Intel 8255 IC. So this 8255 is called PPI, Programmable Peripheral Interface. That means it is used to interface the peripheral devices, and that IC is a programmable IC. So how that IC is programmed according to the given conditions means, inside this PPI 8255 IC, we have one important register which is called CWR. Okay, so CWR stands for Control Word Register. Control Word Register. Okay, so this control word register is a 8-bit register. So according to the given conditions, we have to enable the bits of CWR, and according to that this 8255 will be operated. And this 8255 consists of totally 3 ports. So this is port A and port B. It also consists of port C, but port C is divided into 2 groups, port C upper and port C lower. So all the ports are bidirectional ports. And along with that, using these ports only, we are going to connect the IO devices. And by using this 8255, this is D0 to D7, 8-bit data bus. So using this 8-bit data bus only, this 8255 will be sending information to 8086 microprocessor. And so when the data transfer is performing between IO devices and 8086 through this 8255, all the control signals like chip select, reset, the 2 address lines, read, write, VCC, ground, all these signals will be activated. This is the schematic diagram of Intel 8255 IC. Now, so this is the pin diagram of 8255 PPI. So here, this is a 40-pin IC. Okay. So totally it consists of 40 pins. All these 40 pins will be arranged in the dual inline package. So here you can see the pins from 1 to 20 and 21 to 40. Okay. So here it consists of 3 ports, port A, port B and port C. All these 3 ports are bidirectional ports. So here we can see in the pin diagram, this is port C pins, PC3 to PC7. Along with that, we also have the, all these are the 8 pins related to port C. Along with that, you can see here, these are the 4 bits related to port A, and these are the another 4 bits related to port A. So here you can see these are the bits related to port B. Okay. So and all the ports are here we can see bidirectional ports. So along with this, We also have some control signals like read and A0, A1, and we also have here write and reset signals. So all these are the control signals. And as usual, for any pin diagram, we will have one VCC and one ground signal. So here, this is the VCC which supports plus 5 volts DC supply, and here this is the ground pin. And here this is CS, which is called chip select. It is used for selecting this 8255 IC. And in order to send the information from 8255 to 8086 microprocessor, it is possible with the help of all these 8 data lines. So it is data bus, that is why it is of bidirectional. Okay. So now we will discuss about all these 40 pins of this 8255 IC in detail. Now, so here it consists of 3 ports. The 3 ports are port A, port B and port C. Each port is of 8-bit. So if you see here, this is port A. Port A, it is of 8-bit. So we will have from PA0 to PA7. So this is the 8-bit port. So it acts as either latched output or buffered input pin. So as we have said, port signals are both IO. That means they are bidirectional signals. So in one case they will be acting as input port, another case it will be acting as output port. Okay. So depending on the control word that is loaded into control word register. So as we know, this control word register is a 8-bit register. According to the conditions that you are giving into this CWR, so control word register is CWR. So according to that, 8255 will be operated. And next port is here, port B. So it is also a bidirectional port. It consists of 8 bits. So that is from PB0 to PB7. So it also acts as latched output and buffered input lines. So this is the 8-bit port. So it is used as latch output lines and buffered input lines. So the operation will be same as port A. That means depending on the control word register, this port will be operating. And another port available in 8255 is port C. So port C is also 8-bit, but that 8 bits of port C is divided into lower port C bits, 4 bits, and higher port C bits, that is another 4 bits. So if you see here, this is PC4 to PC7, which is related to higher bits of port C. Okay, so since it consists of 4 bits, we will call it as a nibble. So upper nibble of port C lines, this PC4 to PC7 are called upper nibble of port C lines. They act as either output latch or input buffer. Okay, so generally if we consider port A and port B, those 2 ports can be used to connect the IO devices, whereas here port C lines will be used to produce the handshaking signals. So this port also is used for generating the handshaking signals when it is operating in mode 1 or mode 2. So as we know, if it is operating in the BSR mode, it will be only for port C. If it is operating in the IO mode, it will be under mode 0, mode 1 and mode 2. And another 4 bits of port C or PC0 to PC3. These are the lower port C lines. Okay. And so other details, I mean, its operation will be same as the higher bits of port C. That means these signals can also be used as handshaking signals. So these are the 3 ports that are present in 8255. All these ports are bidirectional ports. So each port is of 8 bit. Now, so another signal here is RD. RD represents read operation. So this signal is used to perform the read operation. Okay. So here when this signal is low, microprocessor is going to read the information from IO device through 8255. So simply we can say using this RD bar signal, microprocessor will read the information from 8255 by using any of the port. And another pin is here WR bar. So this is the input signal. So using this WR bar signal, the microprocessor is going to write the information to 8255 PPI. Okay, so it indicates the write operation. And so we can see here the three signals CS, A0 and A1. So the combination of these three signals will select or they are used to decode the lines that are connected to A0 and A1 of microprocessor. Now we will see by using these three lines how the decoding will be performed. So if you see here, these are A0, A1 and CS bar bits. Okay. So this is by using these three bits, the port selection will be done. Okay. So if the three bits are 000, port A will be selected. If the three bits are 001, port B will be selected. If it is 010, port C is selected. If it is 011, control register, that is nothing but CWR will be selected. So if this chip selection is 1 with any combination, there is invalid combination. Why? Because this CS bar signal is active low signal. It will be operated when the inputs are active low. So if the CS bar signal is active high for any combination, the combination will be invalid. So for each port in the address, it is having fixed address. For port A 80H, for port B 81H, for port C 82H, for control word register the fixed address is 83H. So using this CS, A0 and A1, ports and control word will be selected. And another signals are D0 to D7. So this D0 to D7 are the 8 bidirectional data lines that are connected between this 8255 and 8086 microprocessor. So using this 8-bit data lines only, the information will be transferred between 8255 to 8086 and 8086 to 8255. And another signal is here reset. So when this reset signal is activated, this 8255 IC will be getting reset. That means all the peripheral ports that are set to the input mode. And another one is VCC. Okay. So the maximum power supply required to operate this 8255 is plus 5 volts DC supply. So that is what about the 40 pins that are present in 8255 PPI. And next one is architecture of 8255 IC. So as we know, this 8255 consists of 3 ports. So here the 3 ports are port A, port B, and this is port C. Okay. So all these are 8-bit ports. Each port is a bidirectional port. But here, whereas port C will be divided into 2, port C is divided into 2 nibbles. Okay. So this is the lower nibble and the higher nibble. Now, here, these all IO ports are classified into 2 groups. And here, group A and port C upper will be under the control of this group A, and port C lower and group B, that is port B, these two will be under the control of group B. So whereas this group A and group B will be controlled by this read-write control logic, with the help of all the control signals that are connected. So as we have seen, using this CS bar, A0 and A1, it is used, these three control signals are used to select a proper port or control word register. So we are saying this 8255A is a programmable IC. It can be done with the help of using control word register. So that programming and all will be done with the control word register, which is present in this read-write control logic. And so along with this, we also have control signals like read and write. Okay. So totally, if you see the overview, to all these ports, the IO devices will be connected. And here we will have 8255 PPI in the middle. And all these signals will be connected to 8086 microprocessor. So in this way, we have to connect IO devices to 8086 by using 8255 PPI. That means here read bar, write bar signals of this 8255 should be connected to read bar and write bar signals of 8086 microprocessor. And so in order to transfer any data, that means in order to read or write the information to 8255 by 8086, it should be done with the help of this 8-bit bidirectional data bus only. Now, so this is the data bus buffer. Now we will discuss about all the blocks that are present in this PPI in detail. So here totally it consists of 40 pins. All these 40 pins are arranged in the dual inline package. Now, so totally if you see the blocks that are available in 8255 PPI, so here we can see data bus buffer. And to that data bus buffer only D0 to D7 bidirectional data lines will be connected. And also it consists of read-write control logic, where we have to program by using control word register, and where all the control signals are connected to this read-write control logic block only. And next we will see here group A and group B controls. These two groups will be controlling all the three ports. And the three ports are available: port A, port B and port C. All these three ports are 8-bit bidirectional ports. Now, so coming to the first block, that is data bus buffer. So here, this is a tri-state bidirectional buffer. So using this D0 to D7 lines that are connected to this data bus buffer, it is used to interface 8255 to the system data bus. So using D0 to D7 data lines, data will be transmitted or received from 8255 to microprocessor, or from microprocessor to 8255. So here control words and status information. Here we are saying using D0 to D7 information will be transferred. So that information may be either control word or status word information will be transferred through this data bus buffer block only. And another block is here read-write control logic. So to this read-write control logic, all the control signals are connected. So this is the unit which is having control signals like read bar, write bar. Okay. And also that block, read-write logic block, is used to control the two groups which is called group A and group B. So to this read-write logic control block, we have seen what are different control signals that are connected to that block. So here different control signals are, one is CS, which is called chip select. When this CS bar signal is low, then only this 8255 IC will be operated. Okay. So a low on this pin will enable the communication between microprocessor and 8255. If it is a high, 8255 will not be operated. Another signal is RD bar, read. So this is active low signal. When it is activated, the microprocessor is going to read the information from the ports through data bus buffer. Another signal here is read-write control logic. So using this read-write control logic, those are the two signals. Other signals are also connected to this read-write control logic. One is CS bar, RD bar. Here another one is WR bar. So it represents write operation. So this is active low signal. So microprocessor is going to write the data to the ports. So data or control register. So by using this data bus buffer. And another signal is reset signal. So when this reset signal is activated, it is going to clear the registers that are present in this 8255 IC. So that means it is going to clear this control register and all the ports where IO devices are connected. And another signal is A0 and A1. So these two signals represents the address lines. So with the combination of this A0 and A1, it is going to decide which port and control word should be selected. And another block present in this 8255 PPI is group A and group B controls. Okay. So what is the main purpose of this group A and group B means? So this block will be controlling all the CPU issues. Okay. So that means port A, port B and port C, 3 ports will be under the control of this group A and group B blocks. And another one we have here is port A, B and C. So here group A will control port A and port C higher nibble bits, and group B will control port C lower nibble and port B 8 bits. So, and another one is control word register. So, which is called CWR. It is an 8-bit register. So, we can program this 8255 according to the given conditions into control word register. So, this control word register can only be written into no read operation of control word register is allowed. Okay. So, by using the control word register, only write operation is performed. Read operation cannot be performed from control word register by 8086. Now, so here this 8086 microprocessor is having 3 ports. One is port A, port B and port C. So coming to here, port A, it is an 8-bit port. Okay. So here 8-bit latched buffered output and 8-bit latched input port. And this port A can be operated in 3 modes. So 3 modes are mode 0, mode 1 and mode 2. And another port of 8255 is port B. And this port B is also 8-bit latched or buffered input or output port. So it can be programmed only in mode 0 and mode 1. Coming to the last port, that is port C. So this port C is also of 8-bit. So 8-bit input buffer and 8-bit output latched buffer. So here this port C can be divided into higher nibble and lower nibble. So this port can be divided into 2 4-bit ports, which can be used as control signals for port A and port B. So that is why we will say port C signals generally they will be used as handshaking signals. And this port C can be operated only in mode 0. Okay. So port A, mode 0, mode 1 and mode 2. Whereas port B, mode 0 and mode 1. Whereas port C, it will be operating only in mode 0. Now, so that is what about the architecture of 8255 PPI. Now coming to the ports and modes of 8255A. So this 8255 IC can be operated in two different modes. So here the two different modes are, one is basic IO mode, another one is BSR mode. So basic IO mode represents basic input output mode. So here BSR mode represents bit set reset mode. So these are the two different operating modes of 8255 IC. So out of these two modes, so BSR mode can be operated only for port C signals, whereas basic IO mode can be operated on all the three ports, port A, port B and port C, and it can be performing in the three modes, port A in mode 0, 1 and 2, port B in mode 0 and 1, whereas port C only one mode. Now, coming to the basic IO modes of operation, we are saying that when it is operating in basic IO mode, it is having three modes, mode 0, mode 1 and mode 2. Here coming to mode 0, in this mode, port A and B is used as two 8-bit ports, whereas port C will be used as two 4-bit ports. And so each port can be programmed in either input mode or output mode. So where outputs are latched and inputs are not latched. And so when it is operating in mode 0, ports do not have interrupt capability. So this is what the features when it is operating in mode 0. Now, so when it is operating in mode 1, so in this mode, port A and B is used as 8-bit IO ports. So see here in mode 0, port A and B is used as 8-bit ports, and port C also is used as two 4-bit ports. Whereas when it is operating in mode 1, only port A and port B will be used as 8-bit IO ports. So they can be configured either as input port or output port. Each port uses 3 lines. Okay. So here, especially in this case, since only port A and port B signals are used as 8-bit IO ports, port C signals will be used as handshaking signals. So in this case also, both inputs and outputs are latched. So this is what about mode 0 and mode 1 operating modes of basic IO mode. Now coming to other operating mode, mode 2. So this is also one of the mode in basic IO mode. So when this 8255 is operating in mode 2, in this mode, port A can be configured as bidirectional port, and port B either in mode 0 or mode 1. So in mode 2, port A uses 5 signals from port C in order to perform the handshaking signals during data transfer. Whereas here only 5 signals will be used, but port C is of 8-bit. So here 5 signals will be used for handshaking. What about the remaining 3 signals? Means the remaining 3 signals of port C will be used either as simple input port or output port, or it may also be used as another 3 handshaking signals for port B. So these are the 3 operating modes of basic IO mode. And so here this 8255 IC is a programmable peripheral interface. So we can program this 8255 IC with the help of given conditions. So how you can program means with the help of one 8-bit register which is called CWR. So here CWR stands for control word register. So it is an 8-bit register. So this is the control word register having 8 bits from D0 to D7. Okay. So here, this is the D7th bit which will decide the mode of operation. As we have said, this 8255 will be operated in two modes. One is basic IO mode, another one is BSR mode. So how to decide whether in which operating mode it has to perform means with the help of this D7 bit. So if this D7 bit is 1, it will be operating in basic IO mode. If this D7 bit is 0, it will be operating in BSR mode. And another two bits are D5 and D6 bits, which will decide the mode of operation. Okay, especially this mode of operation is related to port A. Okay, so here this D5 and D6, if these two bits are 0, 0, port A will be operating in mode 0. If these two bits are 0, 1, port A will be operating in mode 1. If the two bits are 1, 0, port A will be operating in mode 2. And next bit is D4. So the D4 bit decides whether port A should be used as input port or output port. So here 8255 consists of 3 ports. All the 3 ports are IO ports. So in order to decide whether to use as input port or output port, if this D4 bit is 1, port A will be used as input port. If this D4 bit is 0, port A will be used as output port. And next bit is D3. So this D3 bit will decide port C upper bit, whether it has to use as input port or output port. So if this D3 bit is 1, port C upper will be used as an input port. And if D3 bit is 0, port 3 bits will be used as output port. And the next bit is D2. So this D2 bit will decide the mode of operation of port B. So if this D2 bit is 0, port B will be operating in mode 0. If D2 bit is 1, port B will be operating in mode 1. And coming to D1 bit, so this D1 bit says whether to use this port B as input port or output port. So if this D1 bit is 1, it will be acting as the input port. If this D1 bit is 0, it will be acting as the output port. And so the last bit is D0. This D0 bit will decide whether to use port C lower bits as input port or output port. So if this port C bit is 1, it will be using as input port. If this port C, that is D0 bit is 0, it will be used as the output port. Okay. So here port C, as we know, it will be operating in only in one mode, whereas port B will be operating in two modes, that is mode 0 and mode 1. Port A will be operating in 3 modes, mode 0, mode 1 and mode 2. So this is what about the control word register and how to program this 8255 by using this control word register. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.